Remember we were talking about the system, so now basically I'm just adding on the boxes so that it will be a system of two boxes that will accelerate with the same accelerations. So basically box A is attached to box B, so every time when they will move with the same acceleration. That's why we call it acceleration of the system. So we're going to go ahead and follow. The first thing we need to be doing is to draw a free body diagram of all the boxes that we have, and due to the forces. I'm just going to go ahead and take only the hanging box into consideration at this point in time. So how many forces acting upon the box? First, from the center of mass, you're going to have the force due to gravity, and also at the same time is attached to the tension. So I'm just going to write out the force of tension. Same thing applies here. So mass A is attached to tension, so I'm just going to write out the force of tension. The reason why I'm labeling the forces of tension the same, because they are actually the same force. And also, that was it. Okay, now we're going to go ahead and look at the system to see whether or not the box will move on a friction or frictionless surface. So at this point, we see the keyword right here is on a frictionless surface. So we don't have to take the friction into consideration. So that makes it much easier for this type of problem. So it doesn't matter whether or not there's a coefficient of kinetic friction is less than static friction, just like what I discussed during on the last video that you saw. So for this one, we're gonna go ahead and I'm just gonna go ahead and do it right here, okay? So I'm just gonna take consideration to mass 2 first, box and mass 2. So I'm gonna pretend like the box is moving this way. So for this box of F2, so the gravity force must be greater than the force of tension. So I'm just gonna go ahead and write down M2G summation of the force is equal to MA. MG plus FT is equal to MA. So that's one of the things we need to know. Why don't I just go ahead and draw it such a way that it will be on a friction. So what if I were to move the force of tension over there, that will become positive, just like what it is right here. And also I will move MA over here too, so that will become negative. So M2G minus M2A. And now I'm just going to go ahead and look at the box M. Box M1. So I'm also doing the same thing, summation of the forces in the y direction first, so that if that's being the case, so I have to draw more of the friction on the forces that acting upon this box M. So that would be force of gravity, and also an object is on the surface, it must be normal force. So that's you got those conclusions from the first law of motion. Not moving right here, so that would be Fn plus minus Fg equal to 0. So the conclusion is Fn is equal to Fg, which is equal to m1g. This is the gravity. This is the force due to the gravity that acts upon box that has mass 1. Now I'm doing the same thing for x directions. So I have only Ft, that was only one force here since we don't have friction force, is equal to Ma. So since I have this equation 1 and this is equation 2, since I have two different equations that has the same thing, so I'm gonna go ahead and set equation 1 is equal to equation 2. So that would be m2g minus m2a is equal to m1a. I'm looking for acceleration, so I'm gonna go ahead and combine these two terms together. So go ahead and put it right here. So it will be m1a plus m2a is equal to m2g. Same thing. m1 plus m2a. I just like set the variable and put it outside the parentheses. So basically this equation and this equation, they're almost the same. So it will be m2g. So if I'm looking for acceleration, so I'm going to divide that one by itself plus m2. I do the same thing for both sides of the equation. That should give me accelerations. So over here, I'm just going to go ahead and write down acceleration is equal to m2g divided by m1 plus m2. And that's actually how you would calculate the acceleration of the system with or without friction. I hope this helped.